All right, so I hope you're excited too. I am going to be starting a new chapter with you. It'll actually be 2 days, and this will be an exciting thing for us. So hope you get as excited as I do too. So anyway, today is the 28th. Let's get going here. And this is section 6.1, and it's called the law of signs. Now, for the problems we're going to be doing, they're going to look something like this, where our angles, we're going to use capital letters, and the sides are going to be the lowercase letter of the angle that they make. So like angle A makes side A, angle B makes side B, and angle C makes side C. Now so far, anytime we've used trigonometry, it was for a right angle. Sine, cosine, tangent, we could use those in inverse sine, cosine, and tangent to solve a right triangle. But in life, things aren't always perfect, as you could see. I mean, you're watching me on the computer or listening to me. I'd rather be in class, and I'm sure some of you feel the same way. But there is a way around it. So if given a non-right triangle, there are a few different things we could do. There's actually 4 different things. One thing is if we're given 2 angles and one side in the configuration where it's AAS or ASA, we could use the law of sines. Also, if we're given 2 sides and one angle, the one angle is opposite one of the sides. We could call it SSA. Both of these techniques, we could use what's called the law of sines. I'll start it today and I'll finish it tomorrow. Sometimes you might just be given 3 sides though. Or you might be given 2 sides and one angle between them. So that's kind of like a side angle side situation. And if you have these 2 cases, we could use something called the law of cosines. There is no law of tangents. All right, so today what we want to focus on is just the law of sines, and we're going to be focused specifically just on that first case. So the law of sines, I always find it interesting because watch how this works. The law of sine says that if you take a side and you divide it by the sine of its angle, you get a number. Let's say the number is 1.5. That's the same number you would get if you took side B and divided it by the sine of angle B. I always just found that interesting. So if you have a proportion, a fraction equal to another fraction, you could just cross multiply and solve. You would have 3 of these things and you'd be missing 1. So you could cross multiply to solve that, a proportion like you learned in Algebra 1. And also that's the same thing as C over the sine of angle C. Now sometimes depending on what book you look at, they might list the law of sines as the sine of A over A equals sine B over B equals sine C over C. But nobody really ever does that. This is the law of sines. This is the one that we're going to be using. The other one's fine too, but that's the one that we use. All right, so let's take a look. We'll do 2 examples here. First example is, what if I told you that angle B was 70 degrees, C was 58 degrees, and side A was 84. So the way we always start these problems is we should always label them the same way. And I always get organized by writing all the components on the side. This helps me know what I have and what I need to find. Alright, so let's see if we can figure this out. Angle A is easy. The way we get angle A is we could just do 180 degrees minus angle B and minus angle C. And if you do that, you would get angle A is 52 degrees. Alright, and that's nice, but we don't have a 90-degree angle, so we can't use the opposite over adjacent and hypotenuse and all that stuff. That wouldn't work if it's not a 90-degree triangle. But looking at the law of sines, you want to try to use a full ratio. So I do have a full ratio right here. Law of sines says that A over the sine of A is equal to B over the sine of B is equal to C over the sine of C. So let's go ahead and fill that in. I know that we have side A is 84, angle A is 52. We don't know side B, but we know angle B is 70. And for C, we know angle C is 58 degrees. So I'm going to use my full fraction, and I'm going to use, I could pick either one, it doesn't matter which one I pick, but I'll use B because it's right next to it. And all I'm going to do is I'm just going to cross multiply and divide to find the missing piece. So 84 times the sine of 70 is equal to B times the sine of 52. We divide both sides by the sine of 52. We'd get that B is equal to, make sure your calculator's in degree mode, 84 sine 70 divided by the sine of 52. Comes out to 100.2. I'm going to label that my triangle. And remember, that's rounded, so I'm going to try not to use rounded answers to get other answers. And we can't use Pythagorean theorem because, again, that's also a right triangle. But what we can use is we can use this one ratio, and we can use this one ratio. And let's do the same thing we just did, but this time we'll solve for side C. 84 over the sine of 52 is equal to C over the sine of 58. Cross multiply and divide just like we did before. And let's see what C is. 84 sine 58 divided by the sine of 52, and my calculator is telling me that it is 90.4. So that's what we're doing. I mean, it's not a big deal. You guys should be able to do this. The new thing is just that law of sines formula. One more example for today. The first example was really an ASA problem. Second problem is going to be a little bit different. So side A is 8, angle A is 49 degrees, and angle B is 57 degrees. Let's draw this out, and we'll get everything set up. And A is 49, B is 57, so we could find the third pretty easily, and side A is 8. All right. This would be an example of an angle-side problem. And let's go ahead and figure it out. So to find angle C, I could do 180 degrees minus 49 and 57. And that would be angle C is 74. Just kind of chipping away at this. And now it looks like we have to use our law of sines. So I'm going to write side A over the sine of angle A is equal to side B over the sine of angle B is equal to side C over the sine of angle C. We're going to do the same thing that we just did. Cross multiply and divide to figure out what side B is. So 8 times the sine of 57 is equal to B times the sine of 49. Divide both sides by the sine of 49. And let's see what we get. Let's see, 8 times the sine of 57 divided by the sine of 49 is 8.9. We can't use Pythagorean theorem, so let's use this fraction and this fraction. We don't want to use that one because that's rounded, so I'm going to use what we're given. Let's cross multiply and divide to finish this one up. C times the sine of 49 is equal to 8 times the sine of 74. We could divide both sides by the sine of 49. Let's see, 8 times the sine of 74 divided by the sine of 49 comes out to be 10.2. So there you go. That's law of sines. I'll show you something pretty interesting tomorrow. We took care of this first case here, but the second case we'll talk about tomorrow. All right, so for homework, what I would like you to please do is on page 434, I'd like you to do numbers 1, 3, and 5. And just ignore if you see like a slash like that or a double slash. You'll know what I mean when you look at it. All right, so good luck. Have a nice day. I'll talk to you soon.